Then the
Okay.
rest will we'll see, okay, what to do. All right. Now, there are a couple of things that are very important here. It's question 6, financial mathematics. You told me that finance and probability are actually what you need to master. And now I want to spend some time on those topics. 12,000 Rand was invested in a fund that paid an interest of M% per annum, compounded quarterly. After 24 months, the value of the investment was 13,459, determine the value of M. Right, so we are looking at question 6. And this question 6 is basically a question from the 2022 matric exam. Okay, right, so we're looking at 6.1. Now, normally in finance, it helps to write down some data, some given information. Right, so we always say A equals, P equals, I equals, N equals. These are the symbols we need to list, and therefore this 12,000 was invested, and therefore that is the principal amount. It was exactly 12,000 there. So this is the principal amount or the present value, P. And then now you have A, the final amount, which became, sorry, the value of the investment. After 24 months, the value of the investment was 13,000. So in other words, it became 13,459. Okay, right. Now the interest rate therefore became was M% compounded quarterly. And so M% means M over 100. Right, is compounded quarterly, so you divide by 4 or you multiply by 1/4, and therefore that becomes M over 400. And then now, obviously, we look at the fact that it was compounded quarterly. Remember, that's what we have. But after 24 months, right, after 24 months, the value of the investment became that. So we have been given the period. So the period actually obviously is 24 months. So we need to convert the months into quarters. So in other words, in 24 months, that is 2 years. 2 years, you multiply the 2 years by 4. And that becomes N equals 8 quarters. Okay, 8 quarters. Right, so when it becomes 8 quarters, you're able to write that one down. But remember that it was 12,000 and then it became what? And then it became the value of the investment became 13,000. So there was an increase. So there was appreciation. So you have A into that. So it increased 13,459 from an initial amount of 12,000, 1 plus M over 400, you raise it to 8. Right, so we're in business. Right, so this here is okay. And now we need to manipulate this. So we're going to divide both sides by 12,000, giving us 13,459, divided by exactly 12,000, which is 1 plus M over 400 to the 8th power. What is this? This is good news, which is exactly 1.121, which is equal to 1 plus M over 400 to the 8th power. So now what do we do here? We take the 8th root both sides. So we're going to take the 8th root. 8th root of 1.121, which is the 8th root of 1 plus M over that So which is the 8th root of 1.121, which is 1 plus m over 400. And then this is the same as the m. Now you can write this one out. So the 8th root of 1.121 minus 1 is m over 400, which means you can cross multiply 400 into the 8th root of 1.121 minus 1, which means m equals. Yes, my dear. All right, so which means m equals that. So you need to use a calculator to finish that off. You can do that. All right, thanks, my dear. Right, just need to use a calculator to finish that off. And when we do, we get the result. And you can easily use the calculator to do it. And what is then the answer to this? Right, so the answer to this becomes exactly m equals 5.78%. And that is the answer. So the answer becomes exactly 5.70%. And that gives us actually the value of m that they wanted there. Okay, right. So that was the finance question. And it was an appreciation question because we see that 12,000 was invested, and investment we expect appreciation and growth, and therefore it wasn't on the reducing balance method with the minus there. Okay. The next question is a bit, yeah. Okay.
Would it give you the same answer if
Yes.
instead of m over 400, you said m over 4?
Okay, that's a good question. Would it give the same answer if you say m over 4? Well, obviously not the same answer. Not the same answer. So always we must divide by 100 first.
Okay.
And then we, because I know that the tendency is to say in a quarter, but you see the different situation that, because if in the exam they say normally 8%, the tendency is to say, okay, you divide by 4 if it's quarterly, you know.
Yeah.
But now what you need to note is first you divide 8 by 100 and then you get 0.08. Okay. And then you divide by 4. So ideally what happens is you then first you say 8 divided by 100 and then you divide it by 4 and then it becomes 8 over 400.
Oh, okay.
Yeah, so because you always write the 0 point something there. So
Yeah.
yeah, that 0 point something means you always divide by what? First by 100 and then by 4. Alternatively, you say, okay, it is 8% and then you divide by 4, which means that it is actually 8 divided by 100. And then because you divide by 4, you multiply by 1/4. Divide by 4 is the same thing. So obviously, I know that this becomes most of the time, this is becoming congested, but this becomes most of the time 8 divided by, okay, it becomes 8 divided by 100, and then you write 0.08, and then you divide by just by 4. Okay, but you must divide the m by 100 first, and then by 4. So there's 100, and then there's a 4. That's why you have 400.
Okay.
If you divide only by 4, then you'd have to bring the 100 somehow. So yeah, it's just going to be some algebra that you'd have to carry out. Okay, right. So let's get moving. And we're looking at 6.2 right now. Right, on January 31, 2022, T-Note deposited 1,000 Rand in an account that paid interest of what? Of 7.5% per annum compounded monthly. Okay, let's continue with the question. He continued depositing 1,000 Rand on the last day of every month. Last day, this is the last day of every month. All right, he will make the last deposit on 31. December 2022. So he will make it on the last day of December. Will Tino have sufficient funds in the account on 1 January 2023 to buy a computer that costs 13,000? Justify your answer by means of inappropriate calculation. Let's look at this one. Okay, this one is about Tino and what Tino is dreaming about and the computer Tino wants to buy. Now, first things first, what is happening here? This one is, what kind of a question is this? So we note down some form of data. What has been given here and what kind of a question is this? Right, Tino deposited on 31 January, he deposited the amount of 1,000 rand in an account that paid interest of that. So now there are deposits. Now these deposits, because he continued depositing this 1,000 rand. So these deposits, we call them X. Always, whether it's present value or future value, but we call these deposits what? X is 1,000 rand. That he continued, continued depositing. Okay, right. Now, at an interest rate of 7.5% per annum, they're compounded monthly. So in other words, you have that I is the interest rate. So you then say 7.5%. Okay, what is 7.5%? You divide it by 100. So that's going to be 0.075. So you already divide it by 100 and then just divide by what? Simply divide by 12 because it's compounded monthly, right? So divide it by 12. What's next? Moreover, the period. You continue depositing on the last day of every month. He will make the last deposit on 31 December 2022. Right, so you have that. Right. Now, the question becomes, how many months are this? Right, or how many deposits are this? Remember that 31 January deposited this. So in other words, it will be for 12 months. So N is 12. 12 times. 12 times. January, February up to December, end of month, Tino is depositing 1,000 rand. Okay, right. So we are so good. Right. So this is awesome. And then they're saying, will Tino have sufficient funds in the account on the 1st of January the next year, 2023? Because this whole thing, these deposits were done in 2022, but now in 2023 January, will Tino have the money to buy the computer Tino is actually dreaming about? So we understand that this is a future value situation. So the question is, how much will Tino accumulate? So we look at the future value and then we say the future value is X into, right? So it is X into 1 plus I to the power N minus 1, all divided by what? All divided by I, which means F equals, what is X? X is 1,000 into 1 plus, what is I? Right, so it is 0.075 divided by what? By 12. Raised to the power 12 minus 1. All divided by what? All divided by I, which is 0.075 divided by 12. It's compounded monthly. So we divide it by 100 and then by 12. So effectively, another way to do this, you can say, okay, our I is actually 7.5 in the attitude of the M. So 7.5, we divide by 100 and then by 12. So you divide by 100 and then you multiply the 100 by 12. So the 12 therefore just multiplies the what? It multiplies the 1, so that you have this, and then you do the calculator work, and then if you use a calculator, you'll get that this will be 12,421,22, which means that this guy is only going to have what? He's only going to have 12,000. It's only going to have 12,000. Now, Tino is only going to have 12,000, but Tino needs what? Tino needs 13,000, so Tino is not going to have the money. Justify your answer by means of an appropriate calculation. Will Tino have 13,000 sufficient funds? Surely this is not sufficient. Sorry, he won't. He won't. Right, so he won't be able. You won't be able to buy the computer. You won't be able to buy the computer because 13,000 minus 12,421 rand and 22 cents is actually 578.78. Okay, so he won't be able to buy the computer because he's not going to have enough money. He's just going to be having only 12,421 instead of 13,000. So it's going to be having less than the mandates required. So if he goes to the shop with 12,000, they will say, hey, you need 13,000, buddy. Okay, so your 12,000 is not going to make it. All right. So just a comment. All right. Right. 6.3 is an interesting one. So that's what the students need to do. This is a November last year paper on finance. Right. 6.3 now. Thabo plans to buy a car that costs 150,000. He will pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. Calculate the value of the loan. 1 mark, easy. Right, so now we look at 6.3, specifically 6.3.1. Right, so what do we do? What is the loan amount? Right, so the loan amount at this point in 6.3.1, it's going to be, remember that he will pay a deposit of 15% and take out a loan for the balance. Right, so a couple of ways to do this. So you can just say, you can just say, he's going to do this. He's just going to say 250,000 minus, so you will pay the deposit of 15%, which means that 15% times 250 which means the loan amount. Okay. How much is the loan amount? So it's 250,000 because Thabo plans to buy a car that costs 250,000. But the situation is that Thabo will pay a deposit of 15% and then take out the loan for the balance. Right. So the question is, how much must he take for the loan? It's going to be 250,000 minus the 15% deposit, because the deposit is going to be paid in advance. And so if you use a calculator, it means that this is 212,500, which means effectively Thabo will have to take a loan for the balance of 212,500. Okay, right. So in 6.3.1, the first payment will be made after 6 months. Will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. Okay, so let's look at this question. Now, at this point, what you need to think about is that the first payment will not be made immediately. The first payment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. 6 months. Six months after loan. You see, then the understanding is that 6 months after loan, it means the final amount will be P into 1 plus R to the power N, and then which means that now this 212 is going to increase, is going to appreciate, because now this guy is going to take long to pay the money, and then it's going to be remember, the interest is 13% compounded monthly, 0.13. Okay, over a period of 6 years, but now it's going to be for 6 months after loan has been granted. The first payment will be made after that. Okay. So let's look at this together. You can write it at the bottom here. So which means that A equals P, which means 212, 500. 1 plus 13%, which means we divide by 100. And then it's per month, so we divide it by 12. Right, so 6 months after the loan has been granted. So now if it's made 6 months, it means the money is going to stay for 5 months. It's going to stay for 5 months. And then you allow 1 month. It's going to be paid 1 month after. So which means if you use a calculator now to do this one, this is exactly 224, 262,53. Well, the meaning is therefore that in 5 months, this money will be worth this. And then if in 5 months, the money will be worth this. Well, this is actually the loan amount. It will now be this. It would have grown a little bit. The fact that you're not paying the loan, then it attracts interest, then it becomes more and more. So by the time he pays, then you'll have to pay a little bit more than he borrowed, or than borrowed. So now it means that the present value formula is at the back of the metric paper, is 1 minus 1 plus I to the power N, all divided by I. So what is the present value? The actual amount of the loan that Thabo needs to pay is 224,262,53. Okay, so this is 1 plus 13%, divide by 100, so it becomes 0.13. You don't only divide by 100, divide by 100, and then divide by 12 because it's compounded monthly. And then now, remember that the loan will be repaid over a period of 6 years. So 6 years is how many months? 6 years. So you must say 12 by 6. So what is 12 by 6? Can you easily get that one? Right, so 12 by 6 after it has been granted. So 12 by 6 is what? Is actually 72. Right, so okay, obviously this one is to the power negative n minus n. So it's 72. Right, so now you need to think and say, how much will this be? You subtract 5 from it. You subtract 5 from it, and then it becomes minus 67. You subtract the 5, so it becomes minus 67. It's 72 altogether, but now the first 5 months will be without payment. So, and during which the loan is going to increase in value, and so there's going to be more money that this guy will have to pay. So you know that one. And therefore, the interest rate is the I is 0.13, but you divide by 12 because it's compounded monthly. All right, so we're now in business. We just solve for x. We divide the 2 to 4 by powers, everything. We solve for x here. Solve for x, we get that it will be actually 4,724. It will be 4,724. It will be 4,700 and what? 4,724 rand and 96 cents. So in principle, it will be 4,724 and 96. That means that Thabo will have to pay monthly 4,724 rand and 96 cents. Okay. So we have answered 6.3.2. Right. The next question is question 9 on calculus. I'm just going to jump that one because you told me it's only finance and probability. So let's look at the next probability question. Question 10. Question 10. We look at 10.1. A, B, and C are 3 events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. 10.1.1. If it is given that the probability that at least one of the events will occur is 0.893, calculate the value of this one A, the probability, calculate the value of Y in the A part. Y is this one. The probability that none of the events will occur. None of the events will occur. So you need to look at these and say, none of the events will occur. So these are the events A, B, and C. So if none of the events will occur, you'll have to then say it is the following. Okay. So you have to say it will therefore be the probability of everything It will therefore be the probability of everything. So in other words, y is going to be the probability of everything minus the probability of at least one of this. Okay, so now the probability of at least one of these occurring will be 0,893, and the result is 0,107. So the probability that at least one of the events, the probability that none of these events will occur is that one, is 0,107. It's 1 minus the probability of at least one occurring. Right, so just note that. Now next is to say, we look at the B part. The probability that all three events will occur. Okay, if all three events occur, then we're looking at the X variable where all of them occur. So how do we find the probability of X? So X will be actually given by, so it will be actually 0,893, which is the probability of at least one event occurring, minus the probabilities outside that, minus the probabilities outside that, and if you add those probabilities outside that, would be 0,733. The probabilities around X, and therefore, which means that X is going to be 0,16. So now, obviously, ask for the probability that all three events occur. It is 0,16. Now, in 10.1.2, determine the probability that at least two of the events will occur. Just at least two of the events will occur. Right, so if at least two of the events will occur, so you have to write the following and say, probability, at least two. At least two events. And this is the same as, right, if at least two events will occur, then you'd have the following. So you'd have 0,1 plus 0,15 to 0,1. Okay, that takes care of two events. 0,15 takes care of two events. And then you have 0,16, which is what we got for X, plus 0,12, 0,2, excuse me, this one. Because now you'd have the event C and the event B. The X and the 0,2 are actually in two events. So either I add the intersection of two events. So as a consequence, you're able to get that if you add all these numbers, you get 0,61. So two events will mean, obviously, if you shade here, you'll be shading the region of intersection of two events. Right, so you have even this one. Okay, so you can shade like that. So just a note there. So the probability that at least two events occur would be 0,61. So at least two, you'd have, you look here, 0,1 is between two A and B, And then B and C, 0, that. You have this one, which is A and C. And then 0.15 is between A and B. So you're good. Okay. Right. The next question is what examiner is looking for, 10.1.3. Are events B and C independent? Justify your answer. Are events B and C independent? Justify your answer. Right, so let's just check that one. Right, so independence of B and C. So now independence, we shall look at it just now. So you need to, in 10.1.3, the probability of B. What is the probability of B? Right, the probability of B would have to be what you get when you actually sum everything within B. Right, when you add everything within B, you actually get 0.643. The probability of everything in C is 0.56. Just add everything in C. And then you look at the probability of B and C. The probability of B and C, B intersection C. So now you focus on the probability of B intersection C. Right, so you add that one up. So B intersection C would be X and 0.2. All right? Would be X and 0.2, for example. B intersection C. And then when you add those, what do you get? Right, so right, I'm just using my calculator here. So you have the B and C. Right, so the probability of B intersection C. Right, so B intersection C in particular becomes what is common between B and C, and the probability of what is common between B and C, right? And so the probability of what is common between B and C is actually 0.36. 0.36. Okay, I'm just checking my answer here as well. Right, so that will be 0.36 because, okay. Right, so obviously you look at the B and C and you add everything up. Okay, I'm just also using my calculator, but it is 0.36. Okay. Right, so you get 0.36. If you add everything in the B and C events, yeah, actually, if you add everything in the B and the C regions, you get exactly 0.36. Okay, right. So the next thing we're gonna do, so that's the probability of what is in B and C. Now, you have the probability of B alone, the probability of C only. Okay, the probability of B only, we already said is 0.643. The probability of C only is 0.56. Okay, those you can take from there. You multiply them. If you use a calculator, you get 0.36. And therefore, it means the probability of B intersection C, B and C, the probability of B intersection C, which is B and C, is the probability of B times the probability of C. The conclusion, therefore, is that the B and C are independent. They're independent because independence is measured by this relation. So if the probability of B and C equals the probability of B times the probability of C, it means we have independent events. Just note that one. Okay, we have independent events there. Right, so we continue. We continue and we look at more calculations. We look at more calculations. Right, so at this point, what is the other question? 10.2. We're looking at a 4-digit code. 4-digit code. Right, so in 10.2, then 10.2.1. A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain digits 0 or 1. Digits may not be repeated, okay? May not contain 0, 1, but may not be repeated. So those conditions are very important. Now, how many possible 4-digit combinations are there to open the lock? How many possible 4-digit combinations are there to open the lock? Okay, so you need to think about this one very carefully. It's a 4-digit code. So the 4-digit code, you can do it in many ways. You can put a digit there, put a digit there, put a digit there, put a digit there. So you have 4 places there. Then after you're having 4 places, because it's a 4-digit code, you're dealing with 4-digit combinations, right? So you need to look at the fact that it must be even numbered, right? So if it is an even numbered code, so it must, now this is very important, that it must be even numbered, but also may not contain the digits 0 or 1. So it means, therefore, you need to make sure that 0 or 1 are out and digits may not be repeated. So there are a couple of things you need to consider. If you look at the digits 0, I'm going to start all of them, write all of them, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, any number in our system of numbering, we use these combinations of this to form billions, millions, etc. Now we need to think about how we can use this. So if it is to be even numbered, what is an even number? So it must be an even number. What is an even number? An even number is a number that ends with a multiple of 2. So it must end with, it may not contain 0 or 1. So it must end with a 2, it must end with a 4, it must end with a 6, it must end with an 8. So you have 1, 1, 2, 3, 4. So in other words, you have 4 choices for the last one, because like 12 is even, because why is the number 12 even? Because the last digit is an even number. So even if you have 104 is an even number because the last digit is what is an even number. So but now at this point you'd be having only 4 possible choices to choose from to make sure that the code is an even number. But also the digits may not be repeated, and suppose you choose a given a given even number, how many digits are you then going to be left with, for example? So you need to count. You need to count how many digits are you going to be left with, for example. Now you can count 1, 2, 3, 4, 5, 6, 7. So you're going to then have 7 choices to put there. After having had 7 choices to put there, you're going to have 6 choices. Because, okay, we have 7 choices, but now you can take this one out. And then you have 6 of them left. And then you can take that one. And then you have 5 choices left. So the question, therefore, is how many possible 4-digit combinations are there to open the lock? 4-digit possible combinations. You multiply all these digits. And if you multiply everything, like with no exception, like everything, you get 840. So how many possible 4-digit combinations are there? So you'll get a possibility of 840 4-digit codes. 4-digit codes. There are 840 of them. Okay, now let's look at the next question. 10.2.2. Calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. Okay. Very interesting codes. Right, so now this was last year's metric paper, 2022. Right, so at this point, this is what obviously you can expect to meet in your test. If you calculate the probability that you'll open the log at first attempt, if it is given that the code is greater than 5,000 and the third digit is 2. So at this point, you will say you start. You start with 579. Okay. You start with 579 or start with 6 or start with 8. So start with 579 or start with 6 or start with 8. Okay. So obviously we're calculating the probability that you'll open the lock at first attempt if it is given that the code is greater than 5,000. Okay, if the code is greater than 5,000, so you do this. How many digits does 5,000 have? 4. So you do 4 of these, like I did before. So you do 1, 2, 3, 4 places. Or in statistics is plus and is times. So you have this, and then you have this plus. Okay, so because if it is given that the code is greater than 5,000, okay, a code that is greater than 5,000, it means that you can start with 5, or you can start with 7, or you can start with 9, or you can start with 6, or start with 8. Okay, obviously you need to look at the fact that you're dealing with all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you look at all of them, the digits that form numbers in our universe, and then say, okay, for example, If you start with a given number, suppose you start with, okay, but remember, you must remove 0 and 1 from this, 0 or 1, right? So, but you can start with this because it must be greater than 5,000. So you can start with 5. Like 5,001 is bigger than 5,000, but it starts with 5. So 5,010 is bigger than 5,000, but it starts with 5. So that is the story. So you start with 5, or you start with 6, or you start with 7, or you start with 8. Right, okay. Suppose you start with 5, 7, 9. 5, 7, 9. So if you start with 5, 7, 9, 5, 7, or 9, it means therefore you have 3 choices for the first digit. Right. You have 6 choices for that digit. But you note that obviously you'd be having a couple of things to consider. So you'd be having either you start with 5, 6, or 7. So that gives you 3. After that, okay, you check that number. Maybe you choose 5, so you cross 5 out. Because you can't start with the 2 because you're smaller than 5, so the number is not going to be bigger than 5,000. Then the question is how many digits will be left. So you need to count those digits that are left, for example. Right, so you'd count and say 1, 2, 3. Okay, you crossed out 5. So in other words, you have 3, right? And then you continue, 5 is out. And then now you continue and say you have 4 and 5, right? So you have 4 and 5. So you have, for instance, a 4 and a 5. But now you need to be careful, right? In terms of which ones you choose here, right? So you choose either 5, 7, or 9, right? So if you choose either 5, 7, or 9, and then now you need to realize that, okay, you have chosen one of them, and then you're left with 7 or 9. So which means that you'd have here, for instance, a 4 there, a 5 there, if you consider this choice. So which means therefore you'd have 5 choices. After having chosen that one, after having chosen like one of them from that, maybe you chose 9, right? So what choice are you going to have then for the other digit, right? So you need to think about the number of choices you're going to have, obviously, for that digit there. But also, you need to also think of the number of choices you're going to have for the last digit, because you have been told that the third digit must be a 2. So if the third digit is a 2, you have one choice. Third digit is a 2, you have one choice. Third digit is a 2, so in the third place, you only have one choice. Okay. Right. So that is one thing you can actually consider there. And then now, if the third digit is 2, so you can't choose many. You can only choose one. You have one choice for that. And then now there's something you need to consider as well. The fact that, so you start with those 5, 7, or 9. Now the question is, obviously the last digit must be even. okay? Because like, in 104, 4 is even, that's why the number is even. These codes are even numbers. So it means, therefore, you can have a couple of choices. What even numbers can you choose from at this point? What even numbers can you choose from at this point? Right, so you need to choose very, very carefully. Right, so for example, if you have to choose, you can have a couple of choices there. Okay, 2 is an even number. You must choose even numbers. 4 is an even number. And then you have, now here, you think about this, but 2 is already out because the third digit is 2. So which means that you can only have those even numbers like 4, and then you can have 8 or 6. This will be 3. Right, so in the same breath, you're gonna have one choice here, 5, 1, 2. By the same reasoning, you're gonna have 1, 5, 1, 2. And then now you continue to multiply this. Okay, I'm gonna put this in a block. What is the answer? Okay, so you multiply this case by case. 45 plus 45 is 3 by 5 by 3. Okay, because 3 by 5 is 15 by 3. 1 by 5 by 2, 10. 5 by 2, 10. And then this is actually 65. Okay, because you're saying that is 10.2.2. Calculate the probability that you'll open the lock at first attempt. So the probability that you'll open the lock at first attempt will be the probability is given by 65 divided by the probability of all possible combinations. The probability of all possible combinations. What are all possible combinations of these? You got them in 10.2.1. And in 10.2.1, we got 840 for all the, because they said how many possible 4-digit combinations are there? Okay, so which means it's 840. And therefore, at the end, it is 13 divided by 168, which is 0.08. Which means the probability that you'll open the lock at first attempt is 0.08. Okay, so it's something that you need to think about. So you need to reason this out. So it's part of the learning curve in learning codes in statistics. Right, I'm sure that you're going to have more practice questions like these to help you to understand this. If you look at question 8, right, this one is about a farmer. A farmer bought a tractor for 980,000, developed the tractor depreciates annually. So obviously at this point, it's similar to what I actually spoke about. So you have to look at the data notion. A farmer bought a tractor for that much of money, but it depreciates. So in other words, what is this kind of story? So we're looking at the 10 at the November 2021 exam. You're with me, right? Okay. So this farmer who bought a tractor for 180,000. And now you need to look at the data and say, write down the data for this situation, but also take into account the fact that we're doing finance. What symbols are applicable here? What kind of symbols are applicable here? So we reason this one together. So obviously you always say A equals, P equals, I equals, N equals. Okay, so you think like that. And then after having thought like that, you allocate everything, every single bit of thing. Let's look at this. Let's look at these. Right, so the farm bought a tractor for 180,000. So in other words, right now the principal is 980,000. The value of the tractor depreciates annually at the rate of 9.2% per annum on the reducing balance method. Right, so this one is 9% per annum, so you divide by 100, so it becomes 0.092. Divide by 100. Right, calculate the book value of the tractor after 7 years, so N is 7. And you have the final value, the final amount is A. Okay, that is question 8. Which means that we're going to use the formula A equals, this is the reducing balance method, which is to the N. So A equals 980, 1001 minus 0.092 to the 7th, so which means you're going to use the calculator to compute this one, and then now what we're getting is 980 into that, which means it is 498,685,82. So which means this is the book value of the tractor after 7 years. Obviously, the tractor would have undergone depreciation then. Would have undergone depreciation then. Okay, so we continue. So now if you look at 8.2, how many years would it take for an amount of 75,000 to accrue to 116,253,50 in an account earning interest of 6.8% per annum compounded quarterly? Let's look at this one. So look at 8.2. Which means this, how many years will take an amount of this to accrue to this? So in other words, it is appreciation this. So we're looking at the data. The present value, the final value, okay. So which means you have that A, okay, is the same as P into 1 plus I to the power N. And this is A, which is 116. Okay, so the final amount becomes that one. And then the present value is 75. And then you take the interest, which is 6.8% compounded to what? Quarterly. So you divide by 100, which is 0.068. Because it's compounded quarterly, there are 4 quarters in a year. So you have 0.068. You divide by 4. You raise it to the power n. N equals how many years will this take? So obviously we're interested in the value of n. But now you always multiply the n by 4 in the finance calculations. So this would be the same as 1,253,5. 0, you divide by 7,000, which is 1 plus 0.068. Divide by 4 to the power 4n. If you divide everything here, it becomes 1,550,046,667, which equals 1,017 to the power 4n. Using the log, take the log on the left, which is 1.55. 0.04667, which equals 4n, the log of 1,017, like that. You divide through, which means that it is 4n, which is the log of 1,550,04667. You divide it by the log of 1,017. If you do this, then this one is going to be exactly 4n, which is 25.99. $6.50 years. So it means, therefore, it will take 6.50 years, because now they're then saying, how many years will it take the amount of 75,000 to accrue to 116,000, etc. 116,253 rand and 50 cents. So it will take 6.50 years for that to happen. Right, Thabo wanted to save 450 in 8.3, 8.3.1. I wanted to save 450,000 as a deposit to buy a house on 30 June 2018. So I wanted to save 450,000 as a deposit to buy a house on 30 June 2018. He deposited a fixed amount of money at the end of every month into an account earning interest of 8.3% compounded monthly. His first deposit was made on 31 July 2013 and his 60th deposit on 30 June 2018. Calculate the amount he deposited monthly. Okay, so let's look at this one. So at this point, you realize that this is a future value question. And the future value is given by f equals 1 plus I to the power n minus 1 all divided by I. $450,000. You want to say 450,000, so which means the future value is going to be 450,000 x into 1 plus. What is the interest rate? It is 8.35 compounded monthly. So which means you divide that one by 100, which means 0.0835. You divide it by 12. Compounded monthly, his first deposit was that. Right, and his 60th deposit on the 30th, so 60th deposit. So in other words, you'd have 60 months, okay, minus 1, all divided by 0.0835, you divide it by 12. So you can get x, divide everything. Okay, if you solve for x here, okay, do the divisions, etc. So you get that this is 6,068 and 69 cents. That is the x. That is the x. Okay, so you continue. You continue. So you have 8.3.2. Right, so if you look at 8.3.2 part A, Tabo bought a house costing 1.5 million and used his savings as the deposit. He obtained a home loan for the balance of the purchase price with an interest of 12% per annum compounded monthly over 25 years. He made his first monthly installment of 11,000 and that towards the loan on 31 July 2018. What will the balance outstanding on the loan be on 30 June 2039? 21 years after the loan was granted. Let's look at this one there. Okay, analyze it together. See what we get. So now we want to find the balance outstanding on the loan. There are a couple of ways to find the balance outstanding on the loan. The easiest one is to use the present value formula and say present value is given by 1 minus 1 plus I to the minus n all divided by I. And then what we're getting is x is 11,058. Okay, so you'll have to look at the fact that at this point, his first monthly installment of 11,000. So in other words, when you look at the this one, the first monthly installment, you put it here as x, 0.85 into 1 minus 1 plus. The interest rate is what? 12%. So you divide it by 100, but it's compounded monthly, divided by 100, divided by 12. So 12% divided by 100 is 0.12, and then divided by 12. Because compounded monthly. And then right, for a period of how many years will this be? Obviously, you're looking at a period of I want to mention that he obtained the home loan for the balance of purchasing purchasing price of the purchase price at an interest rate of 12% compounded monthly over 25 years. He made his first monthly installment towards the loan on 31 July 2018. Okay. Now, you need to look at the fact that to calculate the present value, right, you need to take this first installment and then take it and compute the present value of this over a period of 48 months. Okay, so in other words, I is going to be 0.12 divided by 12, and this is going to be minus 4 years by 12. And then now you do the calculation here, use the calculator, which is 419, 948,32. Right, so you take it back 4 years, exactly. But now it's compounded monthly, so you multiply by 12. Because it's 21 years after the loan has been granted, over a period of 5 years or 25 years. Right, so you have the 4 years, right? So, but you take it, you compound it monthly. Now, I want to also look at another method of the balance. Or alternatively, the balance is calculated differently. Okay, my power will go very soon at 10. Right, so you can also say the balance is also the final amount minus the future value. And this is A is 1 plus I to the n minus x into 1 plus I to the n minus 1 divided by I. Okay, so what is the present value? Right, you realize that the present value is 1,050,000. Right, the present value is going to be exactly 1,050,000. My power is leaving just now. Yeah, 1,050,000 into 12% here divided by 12 times the 21 years minus 11,058 0.85 into 1 plus 0.12 divided by 12. 12 times 21 minus 1, all divided by 0.12 divided by 12. The balance. What is the balance? The power will leave soon. So the balance is going to be 12, 887, 702,20. 12. 467,749,81. So what is the balance? Right, so you do a calculator here. Calculator work, which is 419,952,39. So the balance is going to be this, which is exactly what we got here, 419,948. So it's approximately that. Anyway, so just note that. So that will be, this one is supposed to be part B. 8.32 part B. All right. So obviously now that is the balance.